The total resistance R produced by three conductors with resistance R1, R2, and R3 connected in parallel is 1 over R equals 1 over R1 plus R1 over R2 plus 1 over R3. Find the partial derivative of R, the total resistance, with respect to each of the resistances that is used in that circuit. So we want to use this relation. Focus on the mathematics part of this question, not the physics of this question. As you can see here, the R in this question is not given in terms of R1, R2, and R3. We have 1 over R. And this makes finding these partial derivatives a little tricky. You can do this question in two ways. One way is to use implicit differentiation method to find these partial derivatives. The other way is to use a little algebra, find from this given relation R in terms of R1 and R2 and R3, then find the partial derivatives with respect to each of the variables, which are R1, R2, and R sub 3. And I will show you both methods here for this question. For method 1, I am going to find from this relation R in terms of R1, R2, and R3. Because 1 over R is given this relation. So from that we can say that R equals to 1 over R1 plus 1 over R2 plus 1 over R3. How from this we got this relation? Very simple. We flip the left side and the right side. If we flip the left side, 1 over R would be R. Maybe it's a little confusing for you what happened from this then to here. Attention, all of this is an expression. When you flip anything, suppose you have x. What is the reciprocal of x? 1 over x. And in this case, x is not just each of these separately. All of this plays the role of x. So all of this goes in the denominator and 1 goes in the numerator. So from this relation, we can get R equals that. The other way that you can get same relation that I wrote here is to multiply left side and the right side by R. Then in the left side, this cancels with this. Only you have 1 equals R times 1 over R1 plus 1 over R2 plus 1 over R3. And then if you solve this for R would be 1 divided by all of this, which gives you this relation. Now that we have R in terms of R1, R2, and R3, it's really simple to find the partial derivative of R with respect to each of the variables. Let us start with finding the partial derivative of R with respect to the first variable, which is R1. For finding the derivative of this fraction with respect to R1, we use the quotient rule. Based on the quotient rule, the derivative would be, let me remind you briefly here the quotient rule. When we have u over v, its derivative would be u prime times v, derivative of the top times bottom, minus u, the numerator, times by derivative of the denominator, all over v to the 2. Based on this rule, derivative of the top would be 0. 0 times the denominator is 0, so 0 minus, write the numerator u, which is 1, times by derivative of the denominator. In the denominator we have 3 terms. But attention, we are taking derivative with respect to R1. So derivative of these 2 terms are going to be 0 because we don't have any R1 in them. But what is the derivative of 1 over R1? It's like what is the derivative of 1 over x? Derivative of 1 over x, again based on the quotient rule. Probably you know that it's negative 1 over x to the 2. One way to, other than the quotient rule that you can find this derivative is to write 1 over x simply as x to the negative 1, then use the power rule. It would be negative 1 x to the negative 2. And basically this expression is this. So let's back to our question. So the derivative of denominator with respect to r1 is negative 1 over r1 to the 2. All over the denominator to the power of 2. Multiply the negative that you have here with this negative, then you have 1 over r1 to the 2, all over 1 over r1 plus 1 over r2 plus 1 over r3, all to the power of 2. So the final answer for this question is 1 over r1 to the 2 over this. But you can do a little algebra here to simplify it, and one more thing you can do here to rewrite this answer in a better form. It's completely fine to leave your answer at this step because we wanted to find the partial derivative with respect to r1, and this is the answer. But let me show you how you can simplify this answer and write it in a little better form. Remember the formula that we had here. In here it was 1 over r here. I erase this. We know that from the given relation 1 over r1 plus 1 over r2 plus 1 over r3, focus on here, is equal to 1 over r. So whenever we have this, we can replace all of this with 1 over r. So use that and replace all of this with 1 over r, because from that relation we know that it equals 1 over r. So we can write this as 1 over r1 to the 2 over 1 over r all to the 2. Again, this equals to this from the given equation. Now let's simplify this. So far we know that the partial derivative of r with respect to r1 is equal to 1 over r1 to the 2 over 1 over r all to the 2, which you can write it as 1 over r to the 2. Now we have 1 over r1 to the 2 divided by 1 over r to the 2. In dividing two fractions, we write the first fraction, we multiply by the reciprocal of the other one. Reciprocal of 1 over r2 is r2. So multiply numerator by numerator, denominator by denominator. So the final answer is this. The partial derivative of r, the total resistance, with respect to the first resistance r1 is r to the 2 over r sub 1 to the 2. Because of the symmetry that we have in this relation, you don't need to calculate all the other partial derivatives and do all of this process again. So because of symmetry, we can guess that the partial derivative of r with respect to r2 should be r to the 2 over r2 to the 2. When it was r1, we got r1 to the 2. Now that it is the second resistance, it should be simply r2 to the 2. And what would be the partial derivative with respect to the other resistance? The partial derivative with respect to r3 would be r to the 2 over r3 to the 2. This was one method for doing this question. Now I am going to show you a second method, method 2, to find the partial derivative of total resistance with respect to each of these resistances, each of these variables that here we have in another method. So here I am going to use implicit differentiation for doing the question. Maybe some of you do not remember fully implicit differentiation. What was that? When we have a relation that the function and the variable are mixed together, something like this. Suppose we have x to the 2 plus 3xy plus y to the 2 equals 7. And if you want to find, for example, dy over dx here, because y is not given simply in terms of x, y is not given in terms of x directly, so we say this is implicit relation. And for finding these derivatives, if you remember, we take derivative of both sides with respect to the variable, which in this case is x. So for finding derivative of this with respect to x, we take derivative of the left side and the right side of the equation with respect to the variable. For example, here derivative of x to the 2 would be 2x. Then we take derivative of this part with respect to x, derivative of this with respect to x, and so on. And whenever we get to the variable, to the function, which in this case is the top, which is y, we take derivative normally. Derivative of y to the 2, for example, is 2y, but we multiply by its derivative with respect to x. Let me show you this in this question. We want to find the partial derivative of r with respect to r1. Here, the top variable is our function. The bottom variable is the variable. So the top is dependent variable, the bottom is independent basically variable. The dependent variable is the function, the independent variable is the variable. So attention, we want to take derivative of both sides with respect to r1. So r1 is like x. Let us start. I'm going to start taking derivative of the right side first with respect to r1. The derivative of these two terms with respect to r1 is 0, because r2 and r3 are independent variables. They are variables for themselves. So they are independent to r1. So their derivatives is going to be 0. So only we have to take derivative of this part with respect to r1. And derivative of 1 over r is like 1 over x. You know that its derivative is negative 1 over r1 to the 2. So derivative of the other terms is going to be 0. Now let's look at the left side. Maybe you think by yourself, so derivative of this one should be also 0. No, because based on this relation, we know that r depends to r1. So is a function of r1. So its derivative is not going to be 0. But how we have to find derivative of the left side? Take derivative of all of this expression with respect to variable r. At the end, multiply it by the partial derivative of r with respect to r1. So 1 over r we have. Derivative of 1 over r with respect to r is negative 1 over r to the 2 times this by the partial derivative of r with respect to r1. So basically we use chain rule here to find this derivative. Now let's simplify this. In the left side we have a negative, in the right side we have a negative. Negative with negative cancels, and we are asked to find the partial derivative of r with respect to r1. So it's going to be r to the 2. We multiply both sides by r to the 2 to cancel this. And then in the right side we have r to the 2 over r1 to the 2. If you compare this answer, this final answer here, with the answer that we got from this long process here, you can see that these two answers are the same. Which method is more general and more powerful? Of course, the second method. In the first method, first you have to find r. And sometimes finding the function in terms of the variables is impossible or very challenging. So the better method is the implicit method, which is the second method. As you can see, it is shorter, but you have to remember implicit differentiation, and you can get the answer faster in this way. I hope you like this video. If you like this video, please subscribe in my channel, and see you in the next videos.